Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I'm your host, your host, and as usual in the ghost mode, Mohit Jain. Today we would be taking a few sample questions from 3D mensuration, cylinder, cuboid, then cone, spheres, hemispheres, frustum, buckets, like these kind of questions, which are also very regular at TCS NQT and TCS Ninja, TCS off-campus drives. So the drill is very simple. Please subscribe to the channel and pause the session, try to solve it yourself, then look out for the solution. So on this note, on this happy note, let's begin now. Okay, the first one on the screen, the water from a cylindrical vessel with height 18 meter and radius 3.5 meter is poured into a rectangular vessel, that is a cuboid, of dimension 18 meter and 14 meter. Find the height of the water level. Obviously, the volume of water in cylindrical vessel, that is pi r square h, should be same as volume of water in the rectangular vessel, that would be L into breadth, length into breadth into its height. Or we need to find the value of H1, which is height of the water level. 22 by 7, our radius of cylindrical vessel is 3.5. That can be written as 35 into 35 by 10 into 10, 100. Height is 18 equals here 18 into 14 into H1. We need to find the value of H1. This gone. 7, 5, 20, this is 10, 11, then 7, 5, 7, 2, 5 gone here, 2. So that means H1 equals 11 by 4, 5.5 divided by 2, that is 2.75. 2.75 meter is the height of the water level in the rectangular vessel. Option A is the pick here. A well is in a shape of cylinder. Okay. With height 20 meter and diameter of its base is 4.2 meter. That means radius is 2.1 meter. With the hemisphere with the same base at the bottom. Here we have this hemisphere. Find the volume of the well. So volume of the well is volume of the cylinder plus volume of the hemisphere. Volume of cylinder is pi r square h and volume of hemisphere is 4 by 3 by 2. So it would be 2 by 3 pi r cube. So I'm taking pi r square into h plus 2 by 3 r. So we have 22 by 7, r is 2.1 whole square into h is 20 plus 2 by 3 into 2.1. That would be 0.7. So that is 1.4. We can use our on-screen calculator and find it. So 2 into 0.7, 1.4, that would be 21.4 into 2.1 into 2.1 into 22 by 7. That comes to 296.60 meter cube. Okay, so that is in option A. A rectangular block of solid wood that measures 12 centimeter in length, 24 in width and 30 centimeter by height is cut and made in small cubes. All the like height, breadth and length would be same, each of the same size. What is the minimum number of such cubes that can be made? So to find the minimum number of such cubes that can be made, first we need to find the HCF of 12, 24 and 30. So this is 4 into 3, this is 3 into 8, and this is 3 into 2 into 5. That means HCF is 6. So the side of the cube, the small cube that we can form is 6. So now number of cubes, let it be n. That means n into 6 into 6 into 6 should be equals to volume of the wood. 12 into 24 into 30. 6, 2 times, 4 times and 5 times. 5 into 8 is 40. So minimum number of such cubes that can be made without wastages is 40. Option A fits in. Okay, one more question to deal with hemisphere. The internal and external radius of a hemispherical bowl are 8.5 centimeter and 12 centimeter respectively. What will be the difference between its external and internal area? That would be 2 pi capital R square minus small r square. We just need to put in the value. This is small r internal, this is capital R. So it would be 2 into 22 by 7, capital R square is 144 minus 8.5 square, 8 into 9, 72.25. That would be 44 by 7 into 72, 71.75. So let us calculate. 71.75 into 44 by 7 is 451. So that would be 451 square centimeter. Option A is the fit here. Okay, let's take up a frustum of a cone. A tumbler is in the form of frustum of a cone, the diameter of whose lower and upper surface is 4 and 7. It is something like this. Okay, diameter of the lower part is 4, that means radius is 2, let it be small r. And diameter of the upper part is 7, that means capital R radius is 3.5. We'll join this, that is the height, that is 2. Okay, first we need this slant height. Slant height is root over r minus small r whole square plus h square. So that is 1.5, 2.25 plus 4. That is 6.25. That would be 2.5. Done. Now we need total surface area. Total surface area of frustum is given by pi into capital R square plus small r square plus pi L into r plus small r. We can see that all the options are given in pi. Let's take this common. R square 3 into 4, 12.25. Small r square 2 square is 4 plus L is 2.5. 3.5 plus 2 is 5.5. 5.5 into 2.5 we need. 5.5 into 2.5, that is 13.75 plus 4 plus 12.25. That's give us 30. So this on calculation would be equals to 30 pi. Option A is the fit. That is total surface area in cubic centimeter. But it won't be in cubic centimeter, in square centimeter. Total surface area is in square centimeter. A metallic wire having diameter of the cross section 0.4 centimeter and length 41 2 by 3 meters that will be 1, 2, 3 plus 2, or 125 by 3 meter. That can be taken as height. Cylindrical metallic wire, it can be treated, is melted. So the volume of a cylinder is pi r square h. So pi r is 0.2, 10 pi r square, h, that is in centimeter, h is in meter, 125 by 3, let it multiplied by 100. So now everything is in centimeter. That is the volume of the metallic wire is melted and recast into a sphere. So the volume of the sphere would also be the same. Volume of sphere is 4 by 3 pi, and let the radius of the sphere is r, then it would be r cube. 4 by 3 pi r cube. And if we solve this, we can find the value of r. 10 gone here, 3 gone here, this 4 gone. So r cube is 125, that is 5 cube. That means radius of the sphere is 5 centimeter. The surface area in square centimeter of the sphere. So surface area of sphere is given by 4 pi r square. R is 5. 5 into 5 would be 25, into 4 is 100 pi square centimeter. Good, that we have in option A. Okay, what we have here, we have a cone. A metallic cone of the base radius 7 centimeter and height 12 centimeter is melted. So, okay, volume of the cone, volume of right circular cone that we call, is 1 by 3 pi r square h. 1 by 3 pi r square 49 into h. This is the volume of the cone. This should be equals to form a metallic sphere of radius 2.1. Now, sphere volume is 4 by 3 pi r cube. 4 by 3 pi, here r is 2.1 whole cube, and a plate of length 28 centimeter and breadth 22 centimeter. What is the thickness of the plate? So that would be, volume of the plate would be 28 into 22 into thickness, let it be t. If we solve this, we can find the value. Wonderful. We just need to find each value. Let's have our on-screen calculator. 49 into 12 into 22 by 7 by 3 is 616. So we have 616 on this side. 616 equal 2.1 into 2.1 into 2.1. That is 2.1 whole cube into 22 by 7 into 4 by 3 is 38.808 minus 616. So we have 577.192 for the volume of the plate. That divided by 28 divided by 22 gives 0.937. That is the thickness of the plate. So thickness of the plate is 0.937. When you have on-screen calculator, please use it. Write less, use on-screen calculator more, because time is limited, and in that given 40, 50, 60, 70 seconds, we need to solve it. So answer is 0.937 centimeter, option A. The radius of a sphere and that of a cylinder are equal. So RS is equals to RC. The ratio of radius to the height of the cylinder. Radius to the height of the cylinder is 3 by 4. What is the ratio of the volume? We need, okay, let us do Vs by Vc. Volume of sphere is 4 by 3 pi r cube since both are equal, let me write is at R by volume of cylinder, and volume of cylinder is pi r square h. Pi r square h. Pi gone, square thing gone. So this is 4 by 3 into RC by HC. RC by HC is 3 by 4. So it comes to 1. That means volume would be 1:1. Option A is the pick. So now what we have, again we have a cylinder. The radius of the base of a right circular cylinder partly filled with water is 5 centimeter. A sphere of diameter 6 centimeter is dropped into it and is completely submerged. How much will the level of water rise in the cylinder? Okay, so volume of a sphere is 4 by 3 pi r. R cube, diameter is 3, so r is 3. So it is 3 cube, 3 into 9. This should be equals to volume of the water displaced. Volume of water displaced in right circular cylinder would be pi r square. R is radius is 5 centimeter. R square is 25 into the height or the level by which water is displaced. Let it be h. We just need to solve this. So h is 36 by 25. 36 by 25 will be 1.44. So water displacement is by 1.44 centimeter. Option A. Okay, so this time we have a cube. A cube was completely colored using 3 colors, namely red, yellow and green, in the ratio of 2:3:4. Okay, the price for the same quantity of any color is the same. If the cost of red color used in the cube is 650, that means let the area covered by red color is 2x. That means 2x is equivalent to rupees 650. And the total area covered is 2 plus 3 plus 4, that is 9x. So 9x is 650 by 2 into 9. Perfect. 650 by 2 into 9 will be 2925. So that is the cost for coloring the total surface area of the cube. What will be the cost of painting one face of the cube with green color? Now this is the cost of coloring 6a square. We just need to find that what is the cost of coloring a square. So we just need 2925 by 6. And that should give us 487.5. So the cost would be 487.50. Option A is the pick. So now we have cone and cylinder. The radius of a cone is 2 centimeter and height is 6 centimeter. Okay, so volume of cone is 1 by 3 pi r square h. By what percentage will the volume of a cylinder with twice the height and same radius? Now cylinder volume is pi r square h. So it is twice the height but radius is same. So it would be pi r square. With comparison to cone's height, it is 2h. That would be 2 pi r square h. Obviously this is more. Let this pi r square h be k. So this is 2k and this is k by 3. 2k minus k by 3. By what percentage? Volume of cylinder is more or less than volume of cone divided by k by 3 into 100. That is the answer. So 6 minus 1 is 5k by 3 into 3 by k into 100. Done. 500% more. Option A is the pick again. If the radius of the base of right circular cone is reduced by 60%, That radius was 10. Now the new radius is reduced by 60%. New radius is 4. It got reduced by 6. By how much percentage should the height be increased so that the volume remain the same? That initially height was h, now new height is h bar. Volume remains same of right circular cone. Volume of right circular cone is 1 by 3 pi r square h. So initially it was 1 by 3 pi 100 h. Now this should be equals to 1 by 3 pi. 4 is 16 into h1. So our what? h1 by h is equals to 100 by 16. 425. So if initially h was 4, the new height should be 25. That means it increased by 21 points. 21 points on 4. That would be equals to how much in percentage? 21 into 25. That is 525%. So height should be increased by 525% such that volume remain unchanged. ₹1 coin has a radius of 1 centimeter and width of 1 mm. If 25 such coins are arranged one over another, 25 such coins, what is the volume of the cylinder thus formed? Radius would be 1 centimeter. Height of the cylinder would be 25 mm. Now 1 centimeter is 10 mm, so this is 2.5 centimeter. They have asked to give us the volume of cylinder in cc. Now volume of cylindrical figure is pi r square h, so this will be pi I r square, 1 square h 2.5. So that would be 2.5 pi cc volume. Option A is the pick. Now, with the last sample question, it is from a cuboid. The dimension of a cuboid are length 8, breadth 4 and height 3 meter. What will be the total surface area? Total surface area of a cuboid is 2 into LB plus BH plus LH. That would be 2 into 8 into 4, 32 plus 4 into 3, 12 plus 8 into 3, 24. 4, 8, 3 and 3, 6. 68 into 2, 136 meter square. Yes, that we have in option A. So, thank you everyone for participating. This is Mohit signing off from MJ's Maths and Stats at MJ Magic Studio to you on this hope that you will keep on revising these kind of question. Mensuration 3D, compulsory 2 question in TCS NQT, TCS Ninja. For 3-dimensional figure, please go through cuboid, cube, right circular cylinder, then cone, sphere, hemisphere, frustum, and the question revolves around them for surface area, total surface area or volume. So on this note, I'll see you soon, and yes, I'll see you soon.